right? So what happens if I do, there is a class A, and inside class A there is public void m1, which is calling okay, and which is calling m2, and there, let's suppose there is a int a equals to 10 and then public void m2 and int b equals to 20 and then m3. Cool. Let's take m2 only, and then a dot m2, and when it sends a dot m1. Okay, so we know this much, right, till now. And I mean, we know more, but let's suppose these are two methods, and now what we want to know how the internal memory is working, and when the memory is created and destroyed. Those things we have already learned in theoretical, but we haven't seen it in practical. So runner, so over here what I'm about to do, psvm, this is how we do it, right? And when I run it, then the answer will be a dot m2 then a dot m1, right? The method which starts later ends first. That's why stack memory, last in first out, right? Last line of this method executes first, and last line of this method is executed later. That's why a2 then m1. Okay, cool. Alright, but now we need to do, where we know that this m1, this memory of a in the m1 will be there, right? And this memory will be created when the method is executing, and it will end when the method ends, right? So what usually happens, a stack is created. Okay, let's go to the runner. First, what will happen, a stack of main will be created, right? Because main is the first method, right? So let me just do this and do this. Cool. So main stack is there, and then the stack don't have only memory, it has a lot of things. We will see what, okay, what's happening, what things it can have. For now we will just see that it will have it main memory. What does main memory have? Any variables?
Sorry, come again, sir.
Do main method has any variables?
Yes. No, no, no.
See, this a is a variable, right? Reference variable, a equals to new,
Yeah,
that is a
yeah.
reference variable,
Yes.
right? And over here string argument is also a variable, right? So we will add string. So one string data type args, right? This is an object. So and another is a, right? Reference variable is a. So we have a reference variable a, but the object, this is the stack memory, right? So stack memory will have only, right now let's ignore this array of string. Let's just take example of a, right? But we know that array of string is also there, right? So we are taking example of a. So how will it execute? Before the creation of this, we need to create an object, right? New keyword will try to find the memory in a, in heap area, right? And how much memory it require, it try to go and find the memory in heap, how much memory is in the heap required. So there is no instance variable, right? Only instance variable is required in the heap, because the static variable are already in non-heap memory, and the stack will be in the local memory, right? As there is no variable in heap, so let's add int c equals to, okay, let's don't initialize it. So it requires now 4 byte, right? And the additional byte that it requires for other metadata. So let's assume that it requires 4 byte, then it will go to the RAM and create 4 byte, right? So in RAM we mean heap, right? So let's try to depict heap area over here. So let's say here this is the heap area, and let's type it heap. So in heap area there will be an object of a, and there will be an object of A which will have int C, right? And there is no value provided, and but it's a instance variable, so default value 0 will be provided, right?
Hmm.
So this is the heap, right? And the RAM has its the RAM memory has its numbers, right?
Hmm.
I mean RAM area, like we have house, so in our house we have numbers, right? That
Hmm.
I mean house number 5,
Hmm.
colony this, and
Hmm.
area this. So RAM also has addresses, so it will be having some numeric values. Cool. So at this area this object starts, right? If this object starts from this area, then how much space it requires? It requires just a few more space extra, four more uh, four more bytes more. So from 78 it will be from 82, right?
Hmm.
So I mean, but we are not saying that this area should be representing the memory, but it will be a numeric, right? Because this is the address in the RAM, this 8 7 and something, this thing, right? And we say that our object is pointing to that particular area in heap, right?
Hmm.
So this a variable, what it really holds, we usually depict it by providing an arrow, but this a does not hold the value completely. This just holds this memory address. So it will be holding only this address, right? So now you know what a reference variable holds. It does not hold the object value, right? Like int a, when I say int a equals to 10, then in the stack area a is created and its value 10 is created. So a is literally having the value that we are going to use, right? But in case of object, it holds the address of an area, not the value. Cool.
Okay.
So it holds the address of heap space. And let's say if I do, okay, my bad, let's say if I do a dot something, no, my bad, if I do a dot m1, or if I make this variable public, and if I try to access a dot m1, oh sorry, a dot and variable c, then what will happen? It will go it will go to the a, so it will try to go to the place in this represents, then it will go over here, and then it will try to find the c variable declared at the object, right? This is how it happens. And this is the one thing. So we have successfully created an object and pointed out to our heap area, right? Now the next stack will be created, and which will be the next stack? m1 method, right? So next stack will be created, and that stack will be of m1 method, and post that another stack will be created, right? Let's make the space before, so that we don't have to adjust the space later on. Okay. And that's it. Cool. So now the m1 method, right? So m1 method will also be having some data, right? And let's see if it will have some data or not. We'll go inside the m1 method. There is no variables over here, right?
Hmm.
No parameters, so no variable for there. Then it has int a equals to 10, right?
Hmm.
Then what will happen? In the stack area, a equals to 10 will be there, right? This thing will happen. And then what will happen? M2 will be called, right?
Yeah.
Then M2 will be called, and when M2 will be called, B having the data of 20 will be created, right? B
Hmm.
equals to 20. And then what will happen?
Then again, it will go
Sorry,
to the method.
come again.
So after B, it will go to.
It won't revert. First, it will print this, right? A2 in
Yeah.
console. And then the stack will be destroyed, then entire this stack will be gone, destroyed, right? And then
Hmm.
control flows back to the line number this, right?
Hmm.
Line number 9. So we must keep something, right? How would it know that after completing this I need to go back to this particular method and that to it at this particular line, right? So
Hmm.
somewhere this data needs to be stored, right?
Hmm.
So it will be stored over here, that post completion of this stack m2, oh my bad, I haven't written m2, Post completion of the stack M2, I need to go back at M1 method line number 9. Cool. M1 method line number 9. From that I will continue. So it will do +1 and start from the 10th line. Cool. So it will know from which line it came. Then if when this M2 stack destroyed completely, so it will go back to line number 9, right? Line number 9. Then it will print this a hyphen m1, and then this m1 method completely destroyed. But it also needs to know, right, from where it came. So it came from main method, right? And main method of some class, right? So there will be class runner. So runner and then main method, and then it needs some line. Like for example, oh my bad. Then it requires some line also. Okay, and then this, and line number will be 6, right? Line number 6. And let's say we add this out, runner main. Cool. So if we run this, then m2, m1 and runner, this happened, right? But again, this is, we haven't seen whether it happened in a series wise or not. So what we will do, we will run it in the debug mode. So now we will be able to see everything that I have said till now. So we will be able to see that. See, right now we are at this is stack, right? We are at line number 5. The variables are visible over here. So variables are args only, right? And as soon as I'm done with this line, so the reference variable a will be visible here, because the object of a will be created, right? So it will be visible in the stack area. See, a is this, right? And then 702, right? This is the hash. This is the hash of the address. And then we move inside the, if we need to move inside the m1 method, right? See, we are at line number 6, right? Now see, there will be another stack that will be at the top of the main method. See now, m1. So we
Top
left
of.
from m1 6, main 6 we have left, right? And now we are at m1 8. From main 6 we have left, right? Main 6, visible main 6.
Yeah, visible.
Yes. So from line main 6 we have left. From main 6 we have left, and we have moved to m1 line
Yeah.
number 8, right? Then we will move, and now we will go inside the m2, right? So another stack will be created, right? So see, one more stack. Right now no variables. As soon as I will execute a line number 14, one variable will be there, b, right? This b. And then what will happen, right now the console, if we see at the console is empty, but as soon as I execute this line, so it will print a hyphen m2, right? And now please look at m2, which is executing line number 16. As soon as I execute this line, the stack will be deleted. See, lost it, and then it moved back to line number 10, right? It already had that I need to execute from line number 9. So same thing will happen. See, it will continue from line number 6, but it will do the +1, and the control will go to the 7th line. Cool. So now I am at, okay, wait, okay, cool. So now we will move further. We have executed this line as well, right? In console you can see we have executed a hyphen m1, and I'm at line number 11, right? Still a variable is there, a equals to 10. As soon as I execute this last line, this stack will be destroyed, and I will go to the line number 7, right? I will go back to this line, but it will be executed, so +1 will happen. See, now please look at here, m1 11th line we are executing, and the stack is deleted, right? Now I am at line number 7 of the main, and as soon as I execute this line, then this is printed, right? And as soon as this line executes, ends,
Tense. Yeah.
the main stack also deleted and the system is closed. Done.
Okay, sir.
So this is how it works internally. Everything